An object is launched into the air. Okay, the table shows the object's height above the ground at various times. There's our table. Based on the data in the table, which of the following is closest to the object's height above the ground 9 seconds after being launched? And we have four possibilities here. And the key to this is the word closest. Okay? When we're looking for the one that's closest to the object's height, okay, that's going to allow us to kind of guess. All right? Now, I'm going to completely tear this problem apart, and then we're going to do it a little bit of easier way. First of all, we're going to look at the table. After 1 second, you have t seconds or x seconds, h of x or h of t, where x is the same thing as t. Okay? And after 2 seconds, you're 109. 3 seconds, you're 131 feet in the air. 4 seconds, 143. 5, 145. 637. And we want to know, after 9 seconds, h of x or h of t is going to be what? Now, the first thing we have to know is this formula here. If you don't know this formula, then you're going to have to guess the answer. But we're going to completely pull this problem apart using this formula. Let's try to understand the formula. Where does the 4.9 come from? H of x is negative 4.9 x squared plus bx plus c. What is this 4.9? Well, in physics, you have a formula h is 1/2 gt squared, where g is the acceleration due to gravity, and g is always 9.8 meters per second squared. Now, if you don't know that, then you can't completely pull the problem apart like we're going to do. Okay, you either have to know g is 9.8, and h is half of that, g times t or x squared, or you have to guess the answer. Right now we're going to go with the fact that you know this, and we're going to completely pull this problem apart. You understand what 1/2 of 9.8 is, don't you? Half of 9.8 is this number right here, isn't it? All right, and if gravity's pulling us down and we're headed upward and gravity pulls us down, the acceleration is in a downward form, so that's a minus 4.9 x squared. That's where the 4.9 comes from the acceleration of gravity. Everywhere on the Earth's surface, acceleration of gravity is 9.8. Half of that is 4.9. All right, so anyway, if you know this formula, then we can go with t or x being 1 second. I say h of x, and some people call it t for seconds. In my formula, I use x here, okay? Maybe I should be consistent and use t everywhere, but t is x, same thing, time. Okay, in 1 second now, x squared is going to be 1 squared. X here is 1. Okay, so 1 times 1 is 1, times this number is that number. Then we have our 1 times b plus c. Add 4 to 78, you're going to get 82. All right? So I have one equation based upon the idea or the time of x or t being 1 and h being 78. Now move down to where you have 6 seconds. The height is going to be 137. X here is 6. So you have 6 squared, 6 times b and c. That's 36. 36 times 5. If this were a 5, you'd have 36 times 5 is 180. So we're at 176.4. That's 6b plus c. Leads us to this formula. When you add 176.4 to 137, you get this number. So now I have two equations. One equation here based on the time of 1. Another equation here based upon time or x being 6. And let's write down this equation right here. You have two equations, two unknown. Subtract the second equation from the first equation. Change this sign, and this sign, and subtract them. I'll get 5b, and I'll come up with this number here. Divide both of these by 5. We're getting b to be 46.1. Take my equation here, plug in 46.1. That tells us that c is the difference of 82 and 46. C is going to be 36.8. So now we're going to have 4.9 times t squared, or x squared. Here b is 46.1. C is still 36.8. All right. And we'll plug in a 1 and see how this works. Do I get exactly 78 here? Well, if you square 1, multiply it times this, you get this. If you have 1 times this, you get that. And when you add these up, you get exactly 78. All right? What happens if t is 2? Square 2, you're getting 4. 4 times this number is this number. You have 2 times 46.1. When you add these up, you get 109.4. That compares pretty close with this. And so on. I put on all these numbers and just compare them to give you the actual amounts and compare them with, these are approximations, aren't they? 109.4, and they just say 109. They round it off, I guess. 3, you have 3 squared. 9 times 4.9. 3 times 46.1. Add these up, you're getting 131 exactly. That's pretty close. Pretty close. When you have 4, you're doing 4 squared is 16. 16 times 5 is 80, so you're getting 78. You have 4 times 46.1. Bring down your value for C. Add these up, you're getting 142.8. They rounded it off, didn't they? With 5, when you square 5, 5 times 5 is 25. 25 times 4.9. 5 times 46.1. Add these up. 144.8. They rounded off 145. 6, you're coming up with 137 exactly. Now let's see what we'd get for 9. Take my values here. For 9, h of 9, you have 9 squared is 36. Okay. 9 times this. Put that value. Okay. 36 times 4. Not 36. 9 times 9 is 81. 81 times 4.9. 9 times 46.1. Bring that down. We have 81 times 4. 9 times 40. And 36.8. We're getting exactly 54.8. And that corresponds pretty close. Fill in your chart here with these numbers. That's about 55. So my 4 values, 55 is the closest, because we're getting 54.8. Now, what if you don't know the acceleration of gravity is 9.8? What if you don't know that formula? Well, you're going to have to know a little bit about it. But let's just look at these and see if we can kind of guesstimate what we would have. Okay? Now the vertex, it slows down right here. It went up about 30. It went up about 30. Went up about 10. Goes up about 2. And falls 8. So the vertex has to be between these two values, 143 and 145. So these two, your axis of symmetry lies in between these two. So these two match right here, 143, 145. So that means what? These two would be matching. Fairly close. Okay. All right. Moving away. 2 seconds that would then match with 7 seconds. 1 second would match with 8 seconds. And 0 would come right down here. 0 would match with 9, which means we would want the thing right under 78, the value under 78. Okay? As you march away from this center, the center is in between 4 and 5 seconds. So these two match somewhat. These two would match somewhat. 8 and 1 would match. And 0 and 9 would match. Okay, so we would be looking for something right under 78. Now that's as far as you have to go to pick that 55 value. Okay, that's as far as you go to pick the 55 value. Notice this is, as as you go down, this isn't exactly the same as this. This is a little bit more than this, right? This is a little bit more than this. This value is going to be a little bit more than this is. Okay, these match, and this value is going to be a little bit more than this one. So if you plug in the formula in here, you're going to get something bigger than 36.8, slightly bigger than 36.8. Okay, which would be your 55. So you could start the whole problem from right here, knowing that the vertex lies between those two. You match those two, you match those two, you match those two. You're going to pick the value under 78, which is the 55 value.